Hello and welcome back to the review of my channel by my score EXE. Today we're going to look at more simple statistics and data problems, more specifically about the uses and misuses of the 5 types of representation of data, which are frequency tables, line graphs, pictograms, bar graphs, and pie charts. So yeah, hopefully you enjoyed the video later, and also please subscribe and like this video if you enjoy it. Thank you. Here's question 1. The line graph below shows the sale figures of cars in last year's third and fourth quarters of a car trading company. And what the question means by the third and fourth quarters of a year is that a third quarter means the months July, August, and September, while the fourth quarters will be October, November, and December. As you can see here, we just zoom in. There we go. And we need to find the highest monthly sales and where the monthly sales figures remain constant. And let's just solve part A and part B. So the highest monthly sales according to the line graph is at December, with a monthly sale of 36 if you look carefully at the graph. And as you can see, one grid right here represents one car sold. So the dot right here is 6 grids above 30, which means it's 30 plus 6, which is 36. For part B, which are the months of the sales figures remain constant? Well, as you can see, for it to remain constant, it must be a horizontal line. Unfortunately, we have the horizontal lines between September and October. So those are part A and part B. Now let's just write for part C, which will be the percentage increase in the total sales figure for the fourth quarter compared to the third quarter. And what that means is we need to add up all the sales from October to December and July to September, and then compare their increases. So immediately you can see that the fourth quarter sales are higher than the third quarter sales. So the percentage increase will be the final value, which will be the sum of the frequencies from October to December, which will be 25 plus 32 plus 36 minus the original value, which will be the sum of the frequencies of the sales of the third quarter, which will be 19 plus 15 plus 25 all over the original value, which will be 19 plus 15 plus 25, and then multiply it by 100% if necessary, and you will get approximately equal to 57.6% cracked to 1 decimal place. Finally, for part D, find the total car sales and hence find the average monthly car sales cracked to the nearest whole number. Okay, I'll just let you guys do that. Well, you can just add up all the car sales, which theoretically will be very easy. And then after that, you can use the formula for the average, which is the sum of the frequencies divided by the number of data. So the sum of the frequencies, I'll just leave it that for you guys, over the number of data or the number of frequencies, which will be 6. And theoretically, you should end up with approximately equal to 25, correct to the nearest whole number, as stated in the question. Alright, so that's question 1. Here's question 2. The bar graph shows the distribution of comments of the services of a hotel in a survey. So usually in hotels, people would give reviews to what they think the service of the hotel is for them. So as you can see, there's comments right here. So it ranges from excellent, which is very good, to poor, which is not so very good. For part A, we need to find the percentage of comments which are satisfactory or better. And the comments which are satisfactory or better are excellent, very good, and satisfactory. So for the percentage, we can just sum up all the frequencies for excellent, very good, and satisfactory, which will be, let's see, for excellent, that will be 16. For very good, it will be exactly 30. And for satisfactory, it will be 20. All over the sum of the other frequencies, 60 plus 30 plus 20 plus 10 plus 4 times 100%, which you should end up with 82.5%. For part B, this is a free response question. The manager of the hotel says that it is more appropriate to present the data by a pie chart. So instead of this bar graph, he thinks that it should be more suitable for a pie chart. And your answers may vary depending on the reasons. However, I could say that one possible answer and reasons is yes, because you can check the percentages or the proportions of which comment that you're looking for. For example, if you're looking for the satisfactory comment, as you can see, there are 20 responses. However, if you would imagine it in a pie chart, you can imagine it as a proportion of all the comments. And that is usually helpful for hotels because knowing the proportion of each comment, whether is it good or not, can actually improve the hotel for better services in the future. So that is a possible reason and answer. And that is question 2. Here's question 3. The line graph shows the profits of a company from 2007 to 2011. So as you can see, the x-axis represents the year and the y-axis represents the profits in $1,000. So for example, 40 means $40,000. And for part A, we need to find the percentage increase in the profits from 2007 to 2011. And the formula for the percentage increase, you can recall that it is the final value, which is the frequency for 2011, which will be $44,000. Be careful because the profits are in $1,000, minus the frequency for the year 2007, which will be 40,000 in this case, all over 40,000. And you can multiply by 100% if necessary, and you end up with 10%. So the increase is 10%. Well, I've skipped part B in this case, and we just jump to part C. By observing the graphs, Laura said that the profits in 2011 was 3 times that in 2007. Do you agree with her? And explain your answer. And of course, theoretically, the position of the dot or the point on 2011 is 3 times as high as that in 2007. It doesn't mean that the profits is 3 times as that in 2007, because notice here that the origin of this line graph is not 0, and that is a very crucial error in typically drawing line graphs or bar graphs. So when drawing line graphs or bar graphs, you must maintain, or you must make sure that your origin right here must be equal to 0. So you must start with 0. Or if you're tired to write down all the frequencies from 0 to 44, you can just use, let me just draw that. You can use this symbol right here, which represents that the frequency will skip. So for example, if you have a line graph like this will be 0, and for example this will be 2, and then it will skip to 38. This is an acceptable line graph as long as your origin is at 0, it's comma 0. So that is the answer for part C, and that also has been question 3. Finally, for question 4, this is actually a bonus question that I just decided to add. The bar graph shows the times taken by 3 students to complete a mathematics assignment. By observing the bar graph, can we claim that Ling took 3 times as long as Majid to complete the mathematics assignment? And we also need to explain your answers. And just like on the last question, even though theoretically the bar for Ling is 3 times taller than for Majid's bar, doesn't mean that Ling took 3 times longer. 3 times as long as Majid. This is because, yet again, the origin or the center of the bar graph is not 0. And the solution has been explained in the last question. You can just use the symbol that I just explained. Or another way to observe this is that notice that Ling took 45 minutes while Majid took 35 minutes. And of course, obviously 45 is not equal to 3 times 35. And in fact, this is completely larger than 45. So that is a bonus question for you guys, and that also ends today's video. So hope you guys enjoyed this. Please subscribe for more videos, and I'll see you guys in the next one. Goodbye.